Hello. In this section 2.3, we study differentiation formulas. In this section, we will learn some tools helpful to find the derivatives of a given function. First of all, if we consider the sum, difference, product, and the quotient, also a constant multiple rule. Sum rule. Suppose f is differentiable at some point x, and g is also differentiable at some point, the same point x. Then their sum is also differentiable at that point. Further, we have the derivative of the sum equals the sum of the derivatives. You may think there is a tank, and we put some water into the tank by two pipes. One pipe, at the time x, the volume is f of x. Another one is g of x. If we put water simultaneously, use these two pipes, then at time x, every unit time, the water, the change of the water will be the sum of the two changes. Okay. In fact, the rate of change of the sum of the two functions equals the sum of these two rate of changes is also can be obtained by this derivation. For simplicity, we use and we put the limit later. By definition, this is f of x plus h plus g of x plus h. So the change in the sum of these two, these two functions. But this exactly the sum of two rate of changes. Therefore, if both f and g are differentiable at x, then this will goes to f prime of x. This is g prime of x. Therefore, we have f plus h is also differentiable at x. And by definition, this is the limit of the difference quotient. And this limit is f prime of x plus g prime of x. So you can also express this by f prime plus g prime x. Consequently, if f and g are differentiable on some open-endable, then their sum is also a differentiable function on that open-endable. Okay. On some open-interval I. Okay, I think this already very clear. If we replace sum plus by minus, then we have a difference rule. Summary difference rule. This time, one put in, one out. Okay. So, sum rule and the difference rule. Oh. Oh. Constant multiple rule. If we put water in some tank, use one pipe, but now we use three same pipes. C times f is also differentiable at x, and whose derivative will be c times the derivative of f at x. Okay. One, of course, rate of change is 1. 3, the same time will have 3 times volume. Will be 3 times, not 1 time. Okay, now we have 3, c equals 3. At the time t, the total amount of water is Cfx. Then when time changes from x to x plus h, the change in water will be this one. By definition, this is times x plus h. Aha. Since the distributive law, we certainly have goes to c times f prime of x. Okay, this means that c C f whose derivative at x by definition is the limit of this difference quotient, and our calculation shows under this condition, and by lambda theorem, this limit is c times this limit. Equivalently, this is c times f prime of x. So, multiplied by a constant, then the derivative of a constant multiple, the function equals the constant multiple of the derivative of that function. Product rule. In order to find this derivative, since f is differentiable x, then f is continuous state. Around x, this almost fx. So the effect is just like this one. C now is the number f of x. Fx is gx. Therefore, the rate of change is becomes this one. Also, around x, g of x differentiability implies continuity. This one is almost g of x. Suppose g of x equals c. And this one is c times f of x, whose rate of change is c times this one. Then finally, the rate of change is the sum of these two rate of changes. In order to realize this fact again, just write out the expression. F times g x plus h minus fg x. By definition of this, having the product of two functions okay. This one almost fx, almost a constant because continuous. And g of x, So rewrite this one in this form. See, this term is the original one here, but minus f of x plus h gx. We have to add f of x plus h gx. So this is exactly what we have observed. By constant multiple rule, the rate of change of g is enlarged by f of x plus h times. And also, the rate of change of this one is enlarged by how many times? Constant multiple. Constant multiple of this one. Constant multiple of this one. So we have two functions, f and g. Each function contributes rate of change, but enlarged by another function. Continuity implies, differentiability implies continuity. So this is almost f of x. So here we already use differentiability implies continuity. Okay, as h approaches 0. So when we have two functions and consider their product around x, this one almost a constant, f of x. Almost means maybe with some minor difference here. So the rate of change will be by constant multiple rule, f g will be f g prime. Also, for the function f, around x, g almost g of x, like c times f, the rate of change is c times f prime of x. Constant multiple of this one, constant multiple of this one, and the sum up, okay, because we have two functions. So sometimes the conclusion is hard to read directly, but after the derivation, you will see why this one is correct. This is the product rule. You can read this by the derivative of the product is okay. Differentiate. We use this is a verb. Differentiate a function means to find its derivative, differentiate. So differentiate first. Differentiate fg equals differentiate the first, keep the second, plus keep the first, differentiate the second. So we use this terminology. Differentiate verb is find f prime x. We use this one. To differentiate some function means to find its derivative. So here, this is the derivative of f times g. F times the derivative of g. We can say differentiate fg equals differentiate f keep g plus keep the first one and differentiate the second one. Or you can say the derivative of f and g equals the derivative of first one times the second one plus first one times the derivative of second one. Same. Sometimes we use this verb. 这个叫微分动词，也是求出导数的意思啊。就是微分 f， 并不是说这个是 f 的微分，这是 f 的导数，不要弄错。很多人把这个叫做只知道微分跟积分，不清楚那些里面的名词啊。这个是 f 的导数，不是 f 的微分。这是微分 f 或把 f 微分得到 f 的导数，要弄清楚。Okay, so we already learned some difference, product, and of course now quotient. We don't have this formula, okay? We don't have this formula. You cannot invent a new. I invent a new formula. This one, the derivative of the product of two functions equals the product of two derivatives. No. Okay, because differentiability implies continuity around x. If we focus on f is, this is a multiple of x. How many times? The coefficient is g of x. So we have this one. If we focus on this function, then f of x will be a constant multiple. The coefficient. So we have this. Focus g of, we have this term. Reciprocal rule, if g is differentiable at x and the g of x is non-zero, and this number g at x and this value is non-zero, then this one will be than 0. Okay. Again, intuitively, why we have this strange form, reciprocal. Let's back to the original thinking. Suppose, give a number x, in order to speak the reciprocal, we certainly need the number 1. So suppose this is a 0, this is 1, 2, 3. Suppose g of x, g at x is 3. Suppose, what is the reciprocal of g? 1/3, right? 1/3. So 3 over 1/3 is 9. 9 times. This value is 9 times this value. Right? Yes. Good. Then if we have an increment of x, say h, x plus h, then there will be an increment here, delta g. But when g from here to here, then this one will be moved to the left, because reciprocal is a decreasing function. When x is positive, and also when x is negative. When x is positive, decreasing. When x is negative, also decreasing. So, if the increment of g is positive, then the increment of the reciprocal of g will be to the left. If this one is to the right, then this one will, how to say this? To the, to the sky, to the floor. Okay, to the floor. To the sky means positive, to the floor means negative. No wonder. Because this one equals Therefore, use constant multiple rule or constant multiple rule. This is a constant. And the rate of change is g prime to the right, but the reciprocal will to the left. No wonder we have a minus sign here.